Yes, good morning. Today in Math 111 we're going to talk about section 9.5 entitled Logarithmic Functions, which I would probably refer to informally as logarithms. Alright, first thing, I'm going to try to make this as simple as possible. Logarithms, first and foremost, are exponents. So if you're wondering how to define what logarithms are, well, remember first that logarithms are exponents. In particular, the log or logarithm of x base b is the exponent we put on b, our base, to get x, sometimes referred to as our log argument. Alright, so if I tell you the log of x base b is y, then y is the exponent we put on b to get x. And I can rewrite this equation, well, if y is the exponent we put on b to get x, well, then I can rewrite it like this. I'll say y is the exponent we put on b to get x. Alright, these equations are equivalent. This equation here is in logarithmic form, and this equation right here is in exponential form. They're both equivalent equations. They both say the same thing, one in terms of exponents and one in terms of logarithms. Right, we should be able to go back and forth between log and exponential form fairly easily. Well, let me give you an example of what I'm talking about. Let's say the log of 8 base 2 is 3. That is a true statement. The log of 8 base 2 is 3, and you may ask why. Well, this tells me that 3 is the exponent we put on 2 to get 8. If I write that in exponential form, that says 3 is the exponent we put on 2 to get 8. And of course, 2 cubed equals 8. Again, this equation is in log form. This equation, same equation really, in exponential form. Okay? Let me get a fresh screen here. Alright. Alright. Let's try another one here. Let's say the log of 81 base 3 equals y. And I ask us to solve for y. Well, this equation is in logarithmic form, right? Well, I think it'll be easier to solve if we convert to exponential form. I think we'll see it pretty easily then. Well, if the log of 81 base 3 equals y, that means y is the exponent we put on 3 to get 81. Let me write that. Y is the exponent we put on 3 to get 81. And if I ask you, well, what is the exponent we put on 3 to get 81? Of course, you're going to tell me 4. So y equals 4. Alright. Let's try another one, maybe a little more complicated. The log of 1/36 base 6 equals y, and I'll ask us to solve this equation for y. And again, this equation is in log form. Probably best if we convert to exponential form. This tells me y is the exponent we put on 6 to get 1/36. Y is the exponent we put on 6 to get 1/36. Now, of course, we all remember negative exponents, right? 6 to what power equals 1/36? Well, 6 squared is 36, so 6 to the minus 2 power is 1/36, right? So y here is going to be -2. Okay? Let's try another one. The log of the square root of 7 base 7 equals y. I'll ask you to solve this equation. Well, don't panic. Again, you're starting out in log form here. Probably best to convert to exponential form. Y is the exponent we put on 7 to get the square root of 7. So what I'm really saying here in exponential form, that 7 to the yth power equals the square root of 7. Alright, and I think we can spot this. Well, what number do what exponent do I put on 7 to get the square root of 7? Well, of course, y equals 1/2. We call fractional exponents. We define the 1/2 power as being equivalent to square root. So our answer to this equation is y equals 1/2. Let's try another one. Log of 128 base 2 equals y, and let's solve this equation for y. Alright, y is the exponent we put on 2 to get 128. So converting, I'll say y is the exponent we put on 2 to get 128. Alright, so if 2 to the yth power equals 128, well, I'm hoping you recognize 128 as a power of 2. It's an integer power of 2. 2 to the 7th power is 128. And if both sides of this equation are the same and the bases are the same, of course that means the exponents must be the same. So here y equals 7. Okay. Alright, let's try some more logarithms. Solve this equation. The log of 1 base 8 equals y. Alright. If I start out in logarithmic form, I can convert to exponential form. Y is the exponent we put on 8 to get 1. Well, let's see. This tells me then 8 to the yth power equals 1. Well, you may say 1 is not an integer power of 8. Well, in a way it is. Remember, anything to the 0 power is 1. So if I use the y value 0 here, yes indeed, 8 to the 0th power is 1, because anything to the 0th power is 1. Notice I could have then said if the log of 1 base b is always going to be 0. b to anything to the 0 power equals 1. So the log of 1 any base is 0. Okay. How about now both bases and logarithm arguments can be fractional. Alright, so let's take a look at this one. The log of 1/16 base 1/4 equals y. So this tells me 1/4 to the yth power equals 1/16. 1/4 to the yth power equals 1/16, and I think we can recognize that 1/4 squared equals 1/16. Hence my conclusion, my final answer, y equals +2. Okay. Logarithm of 1/9 base 9 equals y. Solve this logarithmic equation for y. And of course, I'm going to convert to exponential form. 9 to the yth power equals 1/9. 9 to the yth power equals 1/9. And I think we can recognize y. If you don't see it, probably best to write 1/9 as a power of 9. 9 to the minus 1 equals 1/9, so I can then make the conclusion if the both sides of the equation are equal, and if the bases are equal, then of course the exponents must be equal. So here y equals -1. Alright. Let's try another one here. The logarithm of the cube root of 6 base 6 equals y. Alright, now don't panic. Well, all we're saying here, we put this in exponential form. Y is the exponent we put on 6 to get the cube root of 6. And let me rewrite that again. We're starting out in log form here. I'm going to convert to exponential form. Y is the exponent we put on 6 to get the cube root of 6. Well, you'll recall again from our chapter, our section on fractional exponents, the cube root of 6 is 6 to the 1/3 power, is it not? Denominator root, numerator power. Remember we talked about that? So again, I'll say if the equality exists, if the bases are the same, that means the exponents must be the same. So y must equal 1/3 here. Alright, let me get a fresh screen. In a logarithmic equation, or logarithmic function, basically you've got 3 slots typically filled in by either numbers or variables. So if you've got an equation of this type, y equals log x base b, if you're given 2 of those variable values, you should be able to find for the missing third variable. And we've already done that a few times. One comment I want to make is that b values cannot be 1, and we're assumed that base values are positive. So when we're dealing with logarithms, right, we're going to disallow 1 as base, and we're going to disallow negative values as bases. Okay? Let's see. Let's say I give you an equation here, and I'm going to write down, let's see, I'm going to start out with a log equation. And I'm going to say the log of 25 base b equals 2. And I want to solve for the missing base. Notice 2 of those values, x, y, and b, are specified, so I should be able to find the unspecified third value, no matter what position it's in. I'm going to start out in log form. I'm going to convert to exponential form. So 2 is the exponent we put on b to get 25. So that means 2 is the exponent we put on b to get 25. And of course, if b squared is 25, I can solve it very formally, or I could say, well, b equals plus or minus 5. And notice we've made this condition that base values have to be positive, so I'm going to strike the negative values, so our missing base here is positive 5. Okay? And let's march through a bunch of these logarithmic type equations. Alright, in the above example, the missing quantity was a base. Let's see, in here, let's mix it up a little bit. Let's say the missing quantity is the log argument. And again, given any 2, we should be able to find the third. So if the log x base 3 is minus 3, that means minus 3 is the exponent we put on 3 to get x. minus 3 is the exponent we put on 3 to get x. Alright, and I can solve for this x very easily now. 3 to the minus 3 power, that's 1 over 3 cubed. That's 1 over 27, so x here is 1/27. How about again, log arguments can be fractional, log bases can be fractional, and logarithms themselves can be fractional. If I say the log of 1/16 base 1/2 is x, notice here my unknown value is the right side of this logarithmic equation. Alright, so I'll convert to exponential form. This means 1/2 to the x power equals 1/16. 1/2 raised to the x power equals 1/16. Can you recognize the answer? Well, 2 to the 4th power is 16, so that would imply that 1/2 to the 4th power equals 1/16. I claim x equals 4 in this logarithmic equation. How about the log of 49 base b equals 2? Solve for b. Solve for the unknown base. Yeah, maybe this is a little too similar to one we've already done. This tells me b squared is 49. B then would equal plus or minus 7, but with the agreement that base values in logarithms can't be negative, I'll claim b equals positive 7. How about the log of x base 1/3 equals 2? Solve for x. And notice the variable is in a different part of this log equation. Here x represents the log argument. Alright, so converting to exponential form, I'll say 1/3 to the 2nd power equals x, and even I can solve that one. X is going to be 1/9, positive 1/9. And another. Solve the log of 2/16 base 6 equals x. Again, here the x, the unknown, is on the right side of the variable equation, so I claim 6 to the x power equals 2/16 in exponential form. 6 to the x power equals 2/16. Well, I'm hoping we'll recognize 2/16 is 6 cubed, is it not? And if you've got an equality sign between these two expressions and the bases are the same, that means, of course, the exponents must be the same for equality to hold. So x equals 3. Let's try some tougher ones here. Solve the log of 64 base 8 equals y. I'm not sure how much tougher this one is. Well, so y is the exponent we put on 8 to get 64. Y is the exponent we put on 8 to get 64. Okay? Log form, exponential form. So if 8 to the y power equals 64, well, I'm hoping everyone here recognizes 64 as 8 squared. So my response here should be y equals positive 2. The log of 1/3 base 3 equals y. Right, you want to solve for y here. Alright, so converting to exponential form, I get 3 to the y power equals 1/3. 3 to the y power equals 1/3. Well, of course, I know 3 to the minus 1 equals 1/3, so I can just remember this from my earlier work with negative exponents, that y must be -1. What's the log of 2 base 4 equals question mark? Solve for the question mark. Alright, I'm going to convert to exponential form. I claim 4 to the question mark power must equal 2. 4 to the question mark power must equal 2. Now, what exponent on 4 will get me a 2? Well, I think we'll agree that question mark must be 1/2. Right? Well, anything to the 1/2 power is equivalent to square root. The log of 3 base 9 equals, let's call it y. Well, this tells me 9 to the y power must equal 3. Well, I suppose I could be a little bit, this is very similar to the last one. I suppose I could be more formal about it and say, well, 9 is 3 squared. So what we could say is 3 to the 2 times y equals 3 to the first power. Well, of course, if the terms are the same, if the bases are the same, that means the exponents must be the same, so I can conclude 2y equals 1, or of course y equals 1/2. And I'm hoping most people could spot that answer right from here. 9 to the 1/2 power equals 3 without doing it oh so formally. Another layer. Solve. The log of 5 base 125, let's say it equals y. Again, you could name it anything you like, I suppose. Alright, the log of 5 base 125 equals y. Well, that means 125 to the yth power must equal 5. Alright, well, 125 to what power will give me a 5? Do you see it? I recognized 125 as a power of 5. Well, I claim 125 is 5 cubed, is it not? So I can rewrite this equation like this. And when you've got a power of a power, you can multiply the exponents. So I claim 5 to the 3y equals 5 to the first power. And again, I'll say then equivalently 3y must equal 1 and y must equal 1/3 is my final answer. Again, I'm hoping you spotted that answer right here, that the cube root of 125 is 5, so hence an exponent of 1/3 on 125 will give me what I seek. Let's say the log base b of 9/4 equals 2. I'm going to solve for the base. This equation on the left tells me b to the second power must equal 9/4. b to the second power must equal 9/4. Now 9 is a perfect square, 4 of course is a perfect square. Well, that tells me b is plus or minus 3/2, and again we agree that bases must be positive in the land of logarithms. So my final answer here is B is 3/2. Alright, here's one that may tend to trip people up on test day. Let's see, what's the log of 8 base 4? Well, in exponential form, I claim 4 to the x power equals 8. Well, what am I going to do here? 8 is not an integer power of 4. 4 to the first power is 4. 4 squared is 16. We're too big. What are we going to do here? 8 is not a power of 4, but they are both powers of 2, are they not? So here's what I'm going to do. I'm going to say, well, 4 is 2 squared to the x power on the left, and on the right, 8, of course, is 2 cubed. Alright, so multiplying these exponents now, I'll say 2 to the 2x equals 2 cubed. And again, both sides of the equation are the same by definition. The bases are the same. That means the exponents must be the same. And if 2x equals 3, x must be 3/2. So the log of 8 base 4 is 3/2. How about the log of 1/64 base x equals minus 3? Well, let me not call that. I know the book sometimes labels bases as x. I like to label them as b's. Alright, so if we are asked to solve this equation, you're really asking what is the solution to this equation. When b to the minus 3 power equals 1/64, what's b? I'm hoping you recognize the answer as 4, because 4 to the minus 3 power is 1/64. If you didn't see that right off the bat, well, b to the minus 3 power equals, well, 1/64 is 4 to the minus 3 power. And of course, if I've got equality left to right, if the exponents are the same, that means the bases must be the same. So b equals 4. Either formally or informally, often a matter of taste, we should be able to arrive at the correct answer. Alright, what's the log of x, or the log of 1/1000 base x? Again, I'm going to call that a b. Alright, so the log of 1/1000 base b equals minus 3/2. They're starting to get a little nasty now. Let's solve this equation. I claim b then to the minus 3/2 equals 1/1000. Well, I'm hoping we can recognize 1/1000 as kind of a convenient power of 10, is it not? B to the minus 3/2 is going to be, well, 1/1000 is 10 to the minus 3, is it not? Alright, so a little trick I'm going to do here. I notice I've got a minus 3 in the numerator here of that fractional exponent, and a minus 3 here. I can claim on the left hand side it's b to the 1/2 to the minus 3 power equivalently, and that equals 10 to the minus 3 power. So that means these bases must be the same then. So b to the 1/2 equals 10, and if I square both sides, I will have solved for b. b to the 1/2, the square root of b squared is just b, and 100 or 10 squared is simply 100. So b equals 100. That was kind of a tough one. Two more and we'll call it a day. The log of x base 27 equals minus 1/3. You want to solve for x. Well, this equation tells me in exponential form that the base 27 raised to the minus 1/3 power must equal x. And remember, when you've got fractional exponents, denominator root, numerator power. Well, the third root of 27 is 3. And 3 to the minus 1 then is 1/3. So x equals positive 1/3. Last one, the log of x base 36 equals minus 1/2. I'm going to solve for the unknown x value. Alright, in exponential form, this tells me 36 to the minus 1/2 power equals x. Well, what's 36 to the minus 1/2 power? I'll take my square root. The second root of 36 is 6. 6 to the minus 1 power equals x. And of course, 6 to the minus 1 power is 1/6. So my solution there is 1/6. Alright, we'll call it a day, hitting the 32-minute point. And this concludes section 9.5, Logarithmic Functions.